So by the time they were done, there's over 200 kilowatts here of solar, which at the time it was the biggest in the state by far. I think the next closest one was 25 kilowatts. And as they brought it together, essentially this is 8 25 kilowatt systems by 8 different owners that have come together to build it in one large unit to save on the costs, the maintenance, and everything else. And then their output, we take the output of this array, divide it by 8, and then that's applied to their monthly bill through virtual net metering. Virtual net metering is kind of rare in Nebraska. There's only a couple of cities that allow that, to have your solar in one place and actually utilize it as a bill for a meter somewhere else. But it's working out really well for them. We have it now powering our office. Both our Tesla car chargers are powered fully by this. And the bank, the city has some, a couple of retired people have some solar out here. So this is what started it all. And this was the top of the line equipment 5 years ago. These are 255 watt panels. So now 5 years later, these same size panels are at 400 to 425 watts. So they've nearly doubled in the power density per solar panel. And it's really helped a lot, and it's really come a long way. And it hasn't really been slowing down. This 200 kilowatts of solar costs about the same per watt as what, if we turn around behind us now and see the new one, this 500 kilowatt array over here cost just 2.5 years ago. So they're about 2.5 years apart. This is on a solar tracker, and we'll get up here. These rows run north to south. These are 315 and 325 watt panels. And that solar tracker follows the sun during the day. As the sun comes up, they're facing to the east. And as it falls through the day, the sun's just nearly overhead now, so they're facing nearly horizontal. It's all determined by our solar sensors, GPS, the location, the date, the time, everything's considered on the optimum angle of where to keep these. And by utilizing these trackers, we've actually reduced the number of parts that needed to put the whole rack together, and we're gaining 20 to 25% power. In some of our cases, and this is one of them, where we can compare what that static array is doing versus this tracked array, this is sometimes almost 30% more production per day. So it really helps. The tracking adds some cost to the system, but the extra production more than offsets that cost. So anything above about 500 kilowatts or so is going to need to be on a tracked array, or should be on a tracked array to get the max benefit. And the way it works is, these are called the torque tubes, these long horizontal tubes. And this is a 500 kilowatt array. They are connected, and I'm not sure if we can see, but we might want to walk down here. There's 22 rows of these, and they're all connected via a drive shaft down there. So there's one motor down there that runs this entire 500 kilowatt array. That one motor drives the drive shaft, and each one of these rows has its own gearbox in it. And that gearbox is sealed, and it has a clutch in it. So as these come through the day, if it's really windy or one end maybe gets off or torqued a little bit, overnight as these follow the sun, then they come back, and in the morning they actually clutch, turning to the east for about 10 minutes, 5 to 10 minutes. And that just basically realigns the whole system to itself and recalibrates it every day. And that's kind of unique to these array technologies trackers. So every day is like a fresh start, and then they follow the sun, and they keep themselves in sync and start the process all over again. Another thing that's unique about this site is part of it's in a floodplain. And that really came about in Nebraska last year, and even some this summer with all our flooding that we had in the eastern part of the state, well, even here in central part. You can see this is an old parking lot. The ground cover isn't very good here, but it'll start coming in next year because we redid the whole thing. There has been water that's run through this one, and in Fremont, when they flooded so bad last year, their second phase had water, 1.5 feet of water running through it for over 5 days. So the solar can handle, these farms like this can handle the weather and the wind and the rain, but the big question I always get is the hail. How much can they take for the hail? And these are different than the panels you see at somebody's home usually. These are utility scale panels, and they have to meet a much more stringent set of guidelines that they have to meet to qualify. They're much bigger. They're 72 cells. We actually have some new 80 cells that are coming out as well, but they have much more flexibility to them. And under the rating, they actually have to take a 1-inch steel ball bearing at 55 miles an hour, between 55 and 60. And that ball bearing will then be shot at the middle of the panel and then also at the edge, and it has to survive that. Now, that doesn't sound like a very big hailstone, but that's solid steel coming at a 90-degree angle. The hail, you know, we get up to softball size hail here in Nebraska and South Dakota. The hail is more of a conglomerate. It's always coming at an angle. And we haven't really lost too many. I think we've got 78,000 panels out across Nebraska, South Dakota now, and we've lost less than a dozen to hail. Our highest recorded wind gust was in Lexington. It was 95 miles an hour. That actually lasted for like 20 seconds. So I don't even know if that's a gust or a sustained wind. The trackers, we used to put them in a stow position. So if we knew a storm was coming, we would turn them out of the wind via the remote monitoring. They've since upgraded it, and Central City is one of the first to have it. We've added this spring and this hydraulics arm on here. This allows this to withstand winds up to 120 to 130 miles an hour. And that was done mainly for the Florida and the hurricane regions down in the Bahamas, but we've adapted it and brought it up to all the systems in Nebraska now. We don't have to worry about the storms anymore. It can handle anything. When Hastings was being constructed last year, they had a horrible storm with hail. The hail was bad enough and the wind was high enough that it actually killed birds and rabbits and everything and shredded all the corn around the solar system. And we lost one panel that hadn't been installed yet. It was laying on the ground waiting to be installed. So we can really take the weather. This is version 3.5 of this array tracking system. And every version, they try to reduce the number of moving parts, and that's just one less point of failure. The motor seal has a 10-year guarantee on it. They actually have a 30-year lifespan. The gearboxes are sealed, same thing. If the motor does happen to go out, we keep extras in our warehouses across Nebraska. We can switch a motor out in 15 to 20 minutes. We can change a gearbox in less than that. Because uptime is everything on these. Most of these are under a power purchase agreement, meaning that the community or the utility is buying all the power. And we have certain guarantees of the production per year, how much we're gonna make. And the more we make, the more power we make, the more power we can sell to the utility that's agreed to buy it all. So it's really up to the investors and the owners of the systems to make sure that their systems are performing at peak performance all the time monetarily for them. Also, it's usually built into these long-term contracts. Those contracts when I started were 20 years and now the norm is 30 years. Most of the new ones we've got coming up, Lexington and Cozad, to name a couple, are both 30-year contracts. So these are long-term installations out here and they're built to handle the weather. One interesting thing that's happening in Colorado or in Arizona and California now is repowering of systems. So some of their systems are older than ours here, much older, and they're 80 to 100 watt panels. Those panels are being taken off and replaced on the same racking with the larger 400 watt panels. Now that's starting a whole new problem with what do we do with the thousands of the old panels? Well, a lot of times they're reused in water pumping cases or to where there's still a use for a solar panel because they still have a great lifespan left. But the move towards recycling has come a long, long ways. Just got done this morning learning about a discovery out of Moscow to reuse the silicon even better. And then there's an Australian team that has really come up with dealing with everything that's in these, from the low amounts to the heavy metals and things that you hear about. The solar panel recycling market in the next couple of years is going to be huge, and we're really looking for that closed loop system to take everything out of this system and put it right back into a new one or utilize it in some other way, and make sure we're being absolutely as green as possible. Doesn't make sense for us to be out here promoting green energy if we're going to be polluting the environment. And we've actually been able to force through not GenPro specifically, the industry has forced the manufacturers of the cells to even adapt more stringent on their side, more stringent environmental stringent guidelines. Geez, can't think of what I want to say. So we're getting closer and closer. Do these older panels over here have a higher amount of heavy metals and stuff in them? Yes. They've greatly reduced them, and even the newer ones are greatly reduced more than that. And the newer technologies are going to reduce that further. And the way to capture that at the end of the life is getting better all the time too. So I really like to see that part of it. That's a question I get a lot. It's really coming along nicely with the technology. This is a 500 kilowatt array. It's our standard block. There's 22 of these rows. They say a megawatt in Nebraska can power around 200 homes. That's maybe a little high because we use a lot of electricity here in Nebraska. We've got some cheap rates. But so this one's doing 100, 150 homes, offsetting that much power. This one's a little different. The city owns this unit, and they just wanted to have some of their own generation. But they've taken this low cost of electricity and then passed that through by keeping everybody's rates in Central City as low as possible. And it's really worked, being able to offset this chunk, and that chunk is in virtually net metered. Central City became a solar hub kind of by accident. We're here as a company, and then there's also another company called Interconnection Systems that's located in Central City. And between the two of us, I believe we're the biggest solar companies in the state right now, other than the nationwide. I'm part of a group called N Solar. GenPro is the construction arm of that. N Solar is a group that's designed or works directly with the utilities and the municipalities, because we have public power in Nebraska, which is unique. We really want to come together, we have a financing group from Sol Systems, and then Mesner Developments helps us with the community engagement. Between the three of us, we really try to work with that public power to stay engaged and to make sure we keep our rates down and the electricity quality where we want it in Nebraska. And it's worked out great so far. The utilities are doing a great job. We normally train their staff after we leave. We stay on board and monitor all these remotely with full weather stations and full internet capabilities. We can tell if one row of these is out. We can go down to about, if 2 or 3 panels is out, we can know. We'll know if the panels get too dirty to come clean them. Haven't had to do that yet. We get enough rain, enough snow that we haven't had to clean any systems. With our drought conditions we've been having here in Central City, we may end up cleaning these if it doesn't rain in the next week or so. It's getting close. They're getting a little dusty, but haven't had to yet. We get enough rain on and off. So I talked about the remote monitoring, and what's happening here is these solar panels are all connected together, and this is a DC current. So the photon of light from the sun hits the silicon in the panel, knocks loose an electron. That electron bumps into more and just cascades into more and more electrons. Those electrons are gathered here into these wires and brought together in a series parallel configuration. Geez, I'm having trouble talking together. And then those wires are all bundled together in strings, we call them. And they come down here. And if we come right over here to the second row, you can see where the wires from all the rows have been brought together and bundled together into this PD wire, this heavy duty wire. Once again, it's up off the ground, so flooding doesn't really matter. This can actually be up to 6 feet off the ground if we want it. And you'll notice that that wire looks like it's been kind of faded. Like it started out maybe it's hard to see on the video. It started out maybe in shiny red and shiny black. That's not actually true. They're meant to be this. There's a protective powder and a protective coating on that. That wire is designed to be out in the sun and last for 30 years. So even though it looks like it's faded, it's actually basically brand new wire still and has that protective coating. So all that DC electricity is all gathered up into all our strings, and it's brought through and caught into our tunnel system here. Gone through, and we come through to the backside over here, up into our inverters. And this is where the magic happens. These are 60 kilowatt inverters. And so there's 9 of them out here total to get us up to the megawatt, or the half a megawatt. This takes the DC electricity and inverts it to AC electricity, which we need on the grid. Now, it's still not the correct voltage that we need to get onto the grid. We need to up that voltage to push it out to the power line that's way over there to the road. So it's all fed to the AC electric or 480 volt system into our disconnects. These are required. This whole system can be shut off very easily by the utility if they need to. Through the emergency disconnects to the great big transformer here. This ups the voltage to what they need to feed the line, which is way off in the distance. It's actually buried over there. And then this is where we meter everything as well. So not only do we see the production in real time on our system, the utilities get real-time data as well from their side, and to make sure everything's lined up properly and everything's communicating properly. Two separate systems for redundancy on the metering, so we know exactly what this is producing all the time. To monitor that, if we come over here to these boxes, this one doesn't have a full weather station on it, but oftentimes we will have a wind meter, a humidity gauge, a rain meter, everything out here. We didn't have one on this smaller one, but we often do. It's got our GPS locator, it's got cellular antennas, and then on the back of this row here, there's that small bulb there. That's actually an irradiance meter to make sure we're lined up with the sun correctly. All that's gathered into here, and the tracking scrolls, and that all reports in normally in 1 minute intervals, but it's actually connected all the time. So if I need to log into this in real time, I can check everything. We're also have it set up for any alerts. If we lose, if the motor goes down, if we have a voltage drop, if we're shaded, if something's happening, we're gonna get email alerts, text messages, basically however we wanna be alerted, we can set it up. Now, when I first started, I was really surprised at how many alerts I was getting in the middle of the night. But there's a lot of, when we're first setting these up, there's a lot of programming to do. So we figured that all out. But people wondered why I was up all night figuring out what's going on with solar in the middle of the night. Another cool thing about these panels, and the newer ones especially, are efficient enough that a full moon can generate enough electricity that we can measure it. We're creating power under a full moon. So last night, this system was trickling out power with the big moon that we had going on last night. Not sure if it was completely full, but I noticed that we had some solar, or had some lunar output last night. So all of this works together, and on our newest system that's going to be coming up in Norfolk, Nebraska, is 8.5 megawatts. So this is a half a megawatt. It's well, it's 16 times bigger than this. It's essentially going to be just however many blocks it takes to build the 8.5. It's just like a big set, and then they're all connected together to form the big array. And Norfolk's going to be really neat in that it's the first battery in Nebraska, the first utility scale battery. And NPPD is going to use that to offset peaks in demand and things for when the electric grid is really hot, the demand's really high, and the pricing is high. They can use that battery to shave off those peaks and valleys. And really it's going to be a test case, but I think going forward across the nation and the world, the battery storage is going to start being connected to every one of these systems from now on. It's just the new norm, and it really helps you justify the cost and lower your cost of electricity by, if you produce a bunch during the day and have extra, you can then bleed it out from the battery overnight and really turn these systems into to power plants that operate 24 hours a day. So those costs on those batteries are coming down. The technology is really, really cool. We're going to start seeing a lot more of those in Nebraska. OPPD, Omaha Public Power, currently has a request for proposal out for between 400 megawatts and 600 megawatt system. Now, that is utility scale. That is a power plant. That is a huge power plant. Lincoln's got one coming up as well. I think they're between 200 and 300 megawatts, and that land has already been started to be allocated. So each megawatt takes about 6 acres of land. So when you're talking 100 megawatts, that's 600 acres. You know, that's almost a square mile. That is a square mile of land. So that's a lot of panels. That could be 250,000 panels too. So that's a ton of space, a ton of area. And we're seeing the counties and things come together to figure out how are they going to have the zoning regulations and how are they going to make sure that's safe, and all that's coming. But these mega installations are coming to Nebraska. And the reason is they like us. We have a lot of sunny days. Depending on the study you look at, we're either the 10th or the 13th sunniest state in the nation, which surprises a lot of people, surprised me. The western half of the state gets a lot more quality sunshine than the eastern. So our facility in Scotts Bluff versus the one in Fremont, per size of the solar system, the Scotts Bluff, due to their elevation, their lower humidity, and they're more sunny days, produces about 20% more, 15 to 20% more on that side of the state. Didn't think it'd be that much, but it really is. So it helps. The system in Scotts Bluff is comparable to the output of systems in the deserts of California and Arizona, which really surprised me. We thought we had some errors. But what happens is these panels start to lose their efficiency after about 92 degrees. They'll start going down. So in the desert environments, the surface temperature of the panels gets really high and they start losing production. Well, we've got, 6 months of cool weather, more than that, and cold weather. The colder the weather gets, the lower the resistance in all my wires and everything else allows the electricity to flow freer. The sky seems to be much clearer in the wintertime. The lower humidity really helps our generation. So we've got some really good numbers out of Scotts Bluff. Actually, across the state, they're really, really well. The other thing that developers like for these giant ones are cheap land that's not really being used for anything else, cattle grazing, things like that. So they like the cheap land. They like our central location in the country and in the power pool. They like the sunshine. So I think we're going to start seeing a lot more of these giant installations in Nebraska. In fact, there's well over 24 of them proposed across the state that are in different parts of being considered of where they're going to go and what's going to happen. So I think we're going to see the 8.5 megawatt with Norfolk this year or next year is going to be the biggest in the state. That's not going to last very long, and the next one could easily be 10 times that size or 20 times that size. So it's really cool to see, and it's great to see Nebraska embracing it and being able to utilize our land. It's not so evident here with this ground cover because we're reclaiming this parking lot. It's taking a long time, but all of our new systems are including pollinator crops underneath. They take about 3 years to get going. There's a lot of maintenance, but after that, they're all going to have the pollinator blend of grasses, wildflowers, and then even some of them are even talking about doing a low type of shrub or bush that doesn't have any maintenance to it. And Hastings Utilities is working on theirs right now. Lexington is well on their way with theirs. It takes about 3 years of weed maintenance to get it going. They've already talked to people about having beehives at the end of the rows. It's really nice for the bees, provides them with shade, keeps the stress low out of the sun. And then it also really cuts down the wind in here when you get out to the middle. So it lets the bees fly around easier. And it's just a win-win-win all the way around. You're definitely going to see a lot more birds and bees habitats being built alongside these solar systems. It's definitely the new normal now to happen. So that's been great to see as well. And more cities are trying to attract businesses, specifically out-of-state businesses that are coming to town or coming to the state. Microsoft, Google, all the big ones like our labor force, but they demand to have renewable energy of some sort. So the cities are preemptively adding this to their systems and trying to attract new and big businesses, and it's definitely working. I know that they are putting it directly into their economic development portfolios. So it's just a win for Nebraska in every way that I can see. The low points I hear are the size of the systems, taking up that much land, but that land is being used for very little right now. The taxes that a solar system can generate for a community, 100 megawatt system can generate, $1 million a year in tax credit or in tax value. And that's from the nameplate capacity tax. So it can really benefit a school district or the local community with the tax dollars as well, let alone the cheap electricity that's supplied locally right there for the community. So I don't know if we've had any questions. I should have said, if you got questions, feel free to put them in and we'll try to answer them. We've got the 3 projects underway now. Just finished Scotts Bluff. Schuyler is being, second phase is being built right now. Lexington and Cozad, Lexington phase 2 and Cozad will start next here in October. And we were slowed down a bit due to COVID like everybody else. The projects are a little bit behind schedule, but we've come back, and luckily I can isolate my teams out here in the fields to let them keep working, and we're back on schedule now. So tough few months there like it was for everybody, but
right. Yeah, and if you guys have any questions, you can put them in the chat or the Q&A.
I did just look when we got here that in September, since we're in the shoulder month now, we're about halfway between summer and winter. This is operating right now at about 85% efficiency, which is right on where we would expect it. 100%, in June and July, and then it drops off through the winter, and then it starts ramping back up in March and follows the curve.
So somebody asked, how does this work with the federal tax credits that are available for individuals doing their personal project?
Oh, perfect. So there's 3 ways that we can interact with those tax credits. The first way I mentioned was most of our systems are the power purchase agreements. And that just means that the utility or the city is going to buy all that power. Well, the city can't take advantage of the tax credits because they don't take credit. So what happens is that these are all owned by an investment company called Sol Systems that we have partnered with. They have an office in Omaha. And Sol then sells those tax credits or uses them in such a way that it benefits a for-profit business. So the for-profit business likes to invest in these to get their tax credits, and then the city likes to have the power. And the main thing the cities like about it is not only is it the green power for them, the power is locked in at a 0% increase for 30 years. So they don't have to worry about the price of coal going up and down, the price of natural gas going up and down. This price for this amount of electricity is locked in for 30 years. And when you talk to the utility people and their finance people, they really like that idea. So they know what they're going to pay for that electricity for that amount of time. That really helps them out. So that's one way with the power purchase agreements. This one was here in Central City and Aurora and a couple others. They're owned by the city. And that is just to offset. They didn't utilize the tax credit, but they utilized our workforce and their workforce. We were able to come in at a cost that was below or at what they were paying for the electricity now. So they knew that this is going to be out here for 30 years. Same thing, even without the tax credit, it made financial sense for them to do it. And they really wanted to do a test case first. They wanted to see how it would interact with their grid. And that's how a lot of communities, they'll start with a small one that they own and then build a larger one that's a power purchase agreement so somebody can get the tax credits. The third way is Fremont, and Fremont was unique in the country in that it's a community solar program that you could buy into, and you could buy into just buying energy. So if you could buy 150 kilowatt hour blocks. So if your bill was 1,500 kilowatt hours a month, you could buy 10 of those to get you down to 0. Well, they limited that to 80%. So you could offset 80% of your bill by buying your solar energy. The solar energy at the time was a little bit more, but as the rates have creeped up, the solar is about even, and in a couple of years, the solar is going to be cheaper. So you're going to end up. Now, using that method, Scotts Bluff came in and did the same thing. Their electricity from the solar was the first in the state. It was cheaper to buy your energy from the solar than it was from the normal utility. It's all MPPD, but the solar pricing was cheaper than what it was from the conventional sources. So of course, Scotts Bluff sold out immediately because you can lock that price in for 30 years. So homeowners and businesses just snapped it up. What Fremont did was different. Since nobody could take care, they couldn't utilize they own their system. They couldn't utilize the tax credits. If you were just buying energy, there was no way to do the tax credits. They said, why don't we let the people let our customers buy the panels? And thought, wow, that's an incredible idea. Don't know if it's possible with tax laws and the IRS and everything else. We went through all the dealings with the federal government and the IRS. Sure enough, they were open to it and said, no problem. So in Fremont, you could actually buy the panel. We figured out what each panel was going to produce over its lifespan. We figured out the cost per panel. We figured out what it cost the city to insure it, to maintenance and everything else. Came out the price, and I apologize, I don't know what the price is currently because they lowered it. I think it's around $200. You could buy the panel. You could have your own system. You don't have to worry about putting it on the roof. The city took care of all the maintenance. If something goes wrong, the city is really fast to respond and get everything fixed, or we are. So you could buy those panels, once again, offset up to 80% of your bill, however many panels that would be. And we would sent you a list with your serial number and a general location of where your panel was in the farm. And we didn't know if that was going to take off or not. Well, it ended up being about 50% people bought energy and 50% of people bought the panels and took the tax credit and took the depreciation. They really liked it because those panels are giftable or sellable then. Not only get the tax credit, if you moved out of the area, you could transfer those to another person. Actually, there's a waiting list for people. The first megawatts in Fremont sold out in 5 weeks. We were able to fit another third of a megawatt on the site. That sold out another 2 weeks. We immediately started a second site of a megawatt, and it's now 70% sold out, I believe. I haven't looked at those numbers lately. And they're holding some back for economic development. If a big business wants to come to town, they'll have that solar available for them. So just overwhelmed by the response. People really liked it because they could gift it to their children. You could leave their panels in the will. If you moved from one house to another in Fremont, you didn't have to worry about moving your solar panels. It would just follow you. It's just tied to your bill. So we had a big ribbon cutting, and it was windy and cold, and I didn't think anybody was going to show up just to see their solar panels. We had like 100 people showed up, and we're taking pics. You know, they were going out and finding their serial number and taking picture with their panels. So it was really cool. Hastings has since followed suit with a project like that, and it's wide open and available now for people in Hastings. Lincoln Electric System also redefined their system to allow that. And I'm not sure that a couple others are just on the verge of getting that started as well. So after we did that, Brian Newton, the city administrator, whose idea it was, has been asked to talk about, we've done webinars and gone all over the place. That a model of being able to purchase shares or panels has been adopted across the United States now. California, Florida, Hawaii, New Mexico. It's crazy the amount of people that idea originated here in Nebraska. And that's something that I think is pretty cool.
So we had another question. How do you transport the energy from the solar field to the populous areas that need power, such as Omaha or Lincoln?
So we're all part of one big grid, and Nebraska is actually part of a larger grid called the Southwest Power Pool, which is all the states from North Dakota down to Texas. And you can think of these as dripping. These are small, units. They're not giant power plants yet, where they're just dripping electricity into this big swimming pool. And as you pull it out, that you're not really sure where those electrons are coming, but we know the output of this based on the metering. We know the output that you use, and it's just all coming in the pool one end and going out the pool the other end. And we're all just filling this pool all the time. Now, that being said, systems like the majority of our systems are built right next to a town with a load. So we don't have to do many upgrades. In Lexington, for instance, there's a packing plant nearby that has a 5 megawatt cooling system, literally uses 5 megawatts of electricity. Well, the solar's out there producing about 4.5. So we know that most of the time that solar energy, it's going to flow to the closest, least resistant place. It's flowing right into that packing plant. We know that's where the energy is going, but the way it's metered, they're seeing that as electricity they don't have to purchase from elsewhere, and they're using that to lower their overall bill. Now, on some of the systems, Fremont, for instance, we built right next to the coal power plant, so all the infrastructure was already there. We just tied into it, and that makes for some cool pictures. You see the old coal plant with the new solar plant right next to it. Really like that a lot. But for those mega ones I'm talking about, they will be located close to either a substation for a city or a utility, or they will build a new substation with a high voltage line to move it. Solar is a little easier to do that for than wind. The wind's so variable. The solar, we know the sun's going to come up and either it's just going to be this nice curve all day, or it'll be a little fluctuation with clouds. So it's a little easier to design. But yeah, that's a great question. There needs to be infrastructure upgrades, especially on those giant ones. But all the production goes into the big pool, and then all your use comes out. So it's all meter going in and coming back out through this giant pool across the Midwestern states of the United States.
And then somebody asked, who's responsible for the maintenance and upgrades?
That's a great question. So we do a power purchase agreement with the city. Then the investor is under contract for the 25 or 30 years of the agreement. and they have to keep a certain amount of power often that they have to provide per year. So for year one, you have to provide X. And every year there's a slight degradation of about 0.5%. So the next year you lose about 0.5% production. So it's up to them to maintain the system to sell as much electricity as they can. When they're city owned like this, normally what we do is an O&M, operation and maintenance contract, where GenPro, my company, takes care of them, but we also train their guys up as well. So the guys here in Central City really took to it nicely, in Fremont and most of our towns too. Once they get over the initial new technology, you know, kind of scary, and realize that it's quite simple and nothing they haven't dealt with before, they really take to it quite quickly. The maintenance is very low. We quarterly check these. They're, as I said, the monitoring's online 24 hours a day, 365 days a year. Most of the problems can be fixed remotely. Something happens out here, it's replacing a motor or a wire or something like that. Very, very simple. Once a year, we come in and do voltage drop tests and test the panels themselves for degradation. And so compared to a wind turbine or a coal plant or anything, the maintenance on these is multiples lower than what it is on other sources of electricity, which is great. I mentioned how the array technologies really works to remove the moving parts from these. Some of the older tracking systems had a motor on every row, a lot more connections and everything that had to be made. When you bundle everything together and keep it simple, it just really reduces the maintenance cost and the maintenance time.
And then Nathan asks, how do you decide what type slash manufacturer panels you end up using for each project?
That's a great question.
Also, is there a certain technology with respect to panels that you're particularly excited about?
Yeah. Okay, so the first one, we're kind of limited, which is good in my opinion. There's only about 7 manufacturers, several manufacturing facilities, I should say, across the world that can manufacture the utility grade panels. And those panels might be we get them from Vietnam, we get them from Turkey. We're now getting them back from the United States and Canada, thankfully. They can come from China as well. But they have to meet those utility scale. And there's only about 7 manufacturer facilities that can generate these. And then they are branded differently, but the majority of the ones we use are names that you know. We've used a lot of Canadian Solar. Trina is a big one that we use, which has new operations going on the East Coast. So yeah, we're limited, and then we're even limited more. GenPro does work with military bases, and they have an even more stringent set of requirements to meet. So we deal only with 7 manufacturers for this stuff. And years ago, when we started doing the utility grade stuff, we quit buying the residential panels, the smaller ones, because these hold up so much better that if we do something on your home or your business, we're going to use these panels as well. Just because we buy them in volume, they're that much more robust, they can take that much more. We've done a lot of businesses and things in South Dakota where we just use our utility grade panels. It's just easier and better for the customer. What am I excited about? The Perxeovite, I hope I'm saying that right. The new solar cells that are coming is pretty exciting. The multifocal point is pretty exciting. Like I said, this technology, this monocrystalline and polycrystalline silicon they say it's going to top out at 560 watts per panel, but that's what they told me 2 years ago about 400, and now we're at 425. So they keep, all the worldwide development is on this technology currently. So unless something really, a great big discovery happens that we could switch over easily, this manufacturing technique will continue for the next decade or so. But the new chemicals, I should say, are elements that they're able to use and drive down the cost and the efficiency are just going to be bundled into this, I think. But man, the multifocals where there's multiple layers, there's even the new solar things where they're generating power at night versus heat loss and stuff like that. That's kind of cool. I really like the recycling part. I just gave another presentation about that this morning with these new developments of bringing these back and finding value on the old panels and not letting them end up in a landfill or something like that is huge to me. And it's great to see the industry just embracing that and knowing we got to get to it before it becomes a huge problem is what I'm excited about. The batteries too. The batteries are awesome. The batteries have just come down in price so much. The electric cars are coming so fast. That's driven a lot of the technology to allow us to build these utility scale batteries. Just awesome.
And then Mark asked, he said, I've noticed that LES's solar field has panels stuck in one position a lot. They are not tracking. How much trouble have you had with your trackers breaking down?
So yes, I mentioned we did not build the one in Lincoln or in Kearney. It's a different system than the array system you see here. I believe the one in Lincoln has a motor about every third row. And so they can get out of sync. I've noticed that too when I go to Lincoln, that they're often out of sync. I'm not sure that is a large problem for the production. I'm not sure how LES is handling it. I've noticed it too. I'm guessing that we notice it and then hopefully they're fixing it right away. They would definitely know with their monitoring that something's out of whack. I'm just not sure. I'm not involved with that project, so I'm not sure, but I've noticed it too.
And then someone said, on a somewhat related possibility, have you guys looked into solar roadways being developed in Idaho? Will those new types of technology be able to be brought into projects like this?
So yes, the solar roadways and kind of an offshoot of that is the solar shingles as well, the Tesla one, and then there's also the CertainTeed shingle. CertainTeed's already a solar shingle manufacturer, and they've really embraced it as well. They're kind of all linked because they're just the heavy duty drive on it or have the hail on your roof, a tile. We're really excited about that. I've seen a couple of the road tiles. We've had a couple of come through our hands where we tested them out. They're really robust. They're really cool. And that would be, if we could somehow find a way to mass produce that. They've done them in Germany, I believe, and a couple other places. But to make that a replacement for concrete, that would be awesome. The solar shingles, Tesla just reduced their price again. CertainTeed has reduced their price twice. I think that's going to become the norm here in the next couple of years too. We've priced out a housing development in Kansas. It was just over the barrier for them to adopt the solar shingles and the normal shingles. So I think next year at this time, they're going to be able to do a whole housing development as it's built and have the cost be in line to make it happen from the get-go. So really cool technologies. We get to see a lot of cool stuff come through. Micro inverters, the microgrids are coming, working in conjunction with a battery. A lot more homes are going to have the battery in the home, working in conjunction with the electric car and the solar on the roof or in the backyard. That's right around the corner. We have a main home battery that we've sold for the last 2 years. It's about $7,500. They just reduced that cost to $4,000 just overnight. So as those batteries come down, you're going to see a lot more backup applications for the batteries, a lot more time shifting. In Nebraska, we don't have time of day billing yet. I say yet because I'm pretty sure it's coming, where you pay more for electricity during the heat of the day, like in Arizona and California. So what they do there is they charge the battery up overnight and then use it to power the home or the business in the afternoon. They power it with the cheap electricity overnight and then offset the high. That could be coming to Nebraska. So yeah, there's all the development in this is just really fun to be involved with.
It looks like that was our last question. And so I just want to thank you, Jeff, for taking us through the farm and telling us about all the new stuff that's coming up and what's been going on.
Well, thanks for having me. It's been fun.